Hello friends, welcome to my channel. In one of my previous videos, I made a countdown timer using a 7 segment display and a 74HC595 IC. And in this video, I am taking that project forward to display the numbers using a push button, and on each press the numbers will keep on increasing like this. So let's start building this project. Now let us start building the circuit. So first of all, we will connect the wire for the push button. So there are two types of connection for the push button. One is for the input mode and other is for input pull-up mode. So first of all, let me show you for the input pull-up mode. So in the input pull-up mode, you need only two wires to connect to the push button. And when you press the button, both of these wires will get short. And when you not press the button, these two wires will remain isolated from each other. So this black wire will be connected to the ground, that means negative rail of the breadboard. And this green wire will be connected to any of the digital pin on the Arduino Uno, right? Now to connect the push button in the input mode, you need to remove this wire, and in place of this wire, you need a resistor called the pull down resistor, and connect one end of this resistor on the negative rail of the breadboard and other end to the remaining leg of the push button on the same side. And remove this jumper wire from negative end and connect it to the positive end of the breadboard. And connect the jumper wire on the opposite side of the push button. So this will be connected to digital pin. So when you press the button in the input mode, what happens? This pin will be connected to high voltage. Okay. And when you not press the button, this pin remains in the low condition. But in this project, I will use input pull-up mode. So I will not make use of this pull down resistor. So I will make use of only two jumper wires. Now let us make the connection for the display and the 74HC IC. So for the display of the 7 segments, you need to have 7 resistors. You can see 1, 2, 3, 4, 5, 6, 7. And this will be connected to A, this will be connected to B, this will be C, D, E, F, G. Because there are total of 7 segments starting from A, B and all the way up to G. And this second last will be connected to this decimal point display. As you can see, this is for the decimal point. But in this video, I am not making use of this pin. So you can left this pin of the IC. So I have done with all the wirings of the 7 segment display and the IC, and all the wirings are exactly the same as in my previous videos. You can check out from the iTip. The only change is done for the push button. So this is the complete circuit diagram of the project, and as you can see, I am using common cathode display. You can also use common anode. And for the common anode, you need to pull this wire from negative rail of the breadboard to positive rail of the breadboard, and this is the common pin of the display. So this is the only change you need to do for the common anode. And because I am using common cathode, so I will remain this wire on the negative rail of the breadboard. And I am using push button in the input pull-up mode, so that is why I connected terminal 1B to the ground and terminal 2B to the digital pin of the Arduino, that is pin number 5. And I have connected all the segments of the display to the IC with the help of these resistors, right? So all the connections are exactly the same as my previous video. You can check out from the item. So this is the code for the project. I have defined the data pin, serial clock pin and register clock pin, which is also called the latch pin. So these three pins are related with the 74HC595 IC. And I have connected the push button to the pin number 5 on the Arduino. And I have defined all the digits from 0 to 9 in the form of binary numbers. So this is for the common cathode, and for the common anode you need to replace 0 by 1 and 1 by 0. So for the common anode you need to replace only this part of the code. Rest of the lines will remain same. And this is the variable called current digit. So its value will get updated to 1, 2, 3 and all the way up to 9 in each of the loop. And we are displaying the numbers on the 7 segments. So we need to define two states, current button state and the last button state for the push button. And both of the states are currently high. And we need to define two more variables, last debounce time and debounce delay, because you know that push button is a mechanical switch, and when we press the push button, what happens? Instead of one clear low or high pulse, the Arduino consider it as a low or high low and something like that, right? So to avoid that, we need to define these two variables. And debounce delay is equal to 50 millisecond. So if the button stays the same for at least 50 millisecond, the Arduino consider it as a valid press. And in the setup function, we are defining the modes of the various pins like data pin, clock pin, latch pin, and the button pin. And note that button pin is defined with the input pull-up mode. And display digit is a function responsible for displaying the digits on the 7th segment. And in the loop function, we are reading the state of the button pin and storing that state in the this variable, state variable. And we are also checking that if the button's state has been changed by noise or the actual press. That means state is not equal to the last button state, then we are resetting the debounce timer. And if the enough time has been passed since the button was pressed, it means millis minus last debounce time is greater than debounce delay, which I have talked here. Okay. In that case, if the stable state actually changed, button state will be equal to state. And if the button is pressed, that means high to low transition, then the current digit is incrementing by 1. And if the current digit is achieved 9, then in that case we are wrapping around. So the current digit will be reset to 0. And the display digit function is called here. And after this if condition, we are updating the last button state with the current button state. So this is a function called display digit, and it is responsible for displaying the numbers on the 7th segment. And in this line we are calling the number we want to display. And in the line number 72, we are preparing the IC to send the data. That means we are writing low signal to the latch pin. And shift out is the function which sends the pattern bit by bit serially into the IC. And MSB is sent first and LSB is sent at the last. So MSB stands for most significant bit. So MSB is the leftmost digit and LSB is the rightmost digit. And in this line, we are updating the display with the numbers we have sent from this line. So I hope this code is clear to you. If you want any other modification in this project, you can tell me in the comments. We will meet in another project. Till then, goodbye.